Okay, Algebra 2. We skip over section 8.5 and go straight on to 8.6. I am going to separate this into two videos though. So we'll do this first page and then the first example on the back side. Um, and then that will be it for this video, and we'll finish the second half on in the next one. So you should have 8.6 notes, and then there's a couple other sheets of paper that I want you to have out. The first one is this empirical rule sheet, because this just gives you kind of a bigger picture of what the diagram is showing right here in on the notes. So this is just a bigger picture that you can see. And then I also have some more examples that we're going to do together for the 8.6 skills practice and practice. Okay, we're going to do some of the ones from 8.6 practice, and then in the video I'm going to go ahead and post some of the skills practice questions. So you won't have to fill any of these out for homework. I'm going to embed this into the video, but this is kind of the questions that I'm going off of. Okay, so we're going to start talking about normal distributions in this section, which is that symmetric, that bell-shaped curve. Okay, so in the last couple sections we were talking about like positively skewed, negatively skewed. These are all going to be going forward, all going to be symmetric or bell-shaped curved distributions, okay, where most of your data is living here in the middle. So maybe like you had test scores or something that you're talking about, and most of the people scored average in the middle. You had a few people that are on the high end that are scoring in the 100%, and then you had a few people down over here that were scoring in like the 60% or whatever. But for the most part, you have kind of that bell shape. Okay, so these are called normal distributions. When that happens, it's a symmetric or a bell-shaped distribution. When this happens, I need to get a new marker. When this happens, we kind of talked about mean and median at one point in time. Your mean and your median are going to be about the same thing, or about the same number, and they also say mode. Your mean, median, and mode are all going to be located in the center here. So the most frequently occurring data point, the average data point, and the middle data point are all going to be right there in the center. Okay, kind of about the same number is what that will happen. Okay, so that's kind of one way to think about it. The total area that's underneath of a bell curve. Okay, so you have a bell curve here, and what's happening is I'm basically putting 100% of my data underneath of that curve, like kind of in a bar graph form. Okay, so he's doing one of those, and there's 100% of my data that lives underneath of there. Okay, so then they're going to start to incorporate something called standard deviation. Standard deviation. Okay, and I kind of talked before about standard deviation when we had the two data sets that was like the 2013 test scores and was it test over chapter 3 and test over chapter 4. And I said like the test over chapter 4 was just like this stuff, and the test over chapter 3 was like looked kind of like this instead. And I said the test over chapter 4, those scores were a lot closer together, which means his standard deviation is a lower number. Okay, and the way that a standard deviation works is if you look at this empirical rule sheet, okay, your average will always be this number here in the middle. So the average of your data set maybe is, I don't know, let's say 80, okay? So the average score on a test was an 80%. And then let's say our standard deviation, just for an example, is 5, okay? So if our standard deviation is 5, then what's going to happen is I would take and add 5 over here to get 85, and I would subtract 5 over here to get 75. Okay, now the empirical rule says, this is some guy that came up with this rule, that said according to the average and according to the standard deviation, just about 68% of your data, or 68% of the people who took that test, will have scores that are 5 units on, or 1 standard deviation on either side of your average. So if our standard deviation is 5, that means that 68% of my people scored between a 75 and an 85. Okay, now if I add another standard deviation, this is like plus 2 S's, so it would actually be like plus 5 more than the 85. This would be 90 right here. This would be 70. Okay, this guy came up with this rule and said that 95% of your people are going to probably score between 2 standard deviations. So I would say that 95% of you guys that took a test for me would have scored between a 70 and a 90. Now, 95%, there's still 5% of you that would have scored maybe lower than a 70 or above a 90, right? And that has to do with 3 standard deviations, okay? So a third standard deviation would be, if I add 5 more to this, would be a 95 and a 65, okay? Now if we look at that, this guy says that according to the empirical rule, 99.7%, so just about all of you, would have scored between a 65 and a 95 on whatever test I gave you, right? Now that still gives me 0.3% that could be, higher than a 95, or 0.3% that could be lower than a 65, but that's kind of how that works out, okay? Now, what these numbers are in here is 68%. They went ahead and separated that out into 2 equal pieces, okay? So if there's 68% of the people who live between 75 and 85, then that means that half of those people, 34%, would be between an 80 and an 85. So 34% of you, or about a third of you, would have scored between an 80 and an 85. Another third of you probably scored between a 75 and an 80, okay? And now that, again, that's just using the example that my average, they call it an X bar. My average is 80 and my standard deviation is 5. If my standard deviation was different than that, we would have to use different numbers. But that's just kind of how this empirical rule breaks down, okay? Now, the higher the standard deviation, the more spread apart your data is. So if my standard deviation was 10 instead, okay, this average would be 80, this guy would be 90, this guy would be 100, right, because I'm adding 10 every time. This would be 70, this would be 60, this would be 50, this would be 110, which you really can't probably go that high, but maybe there's bonus points, okay? So in that case, instead of 68% of my data being between 75 and 85, it would be between 70 and 90, okay? So it's just based upon whatever your standard deviation for your data set is, okay? All right, so let's go and look at one of these examples here. So in example 1, so this bell curve is just the same as what the other one was. I just kind of have it written a little bit bigger for that other one, okay? So part A, it says a normal distribution has a mean of 21. When that happens, I always put 21 here in the middle. And I kind of maybe draw a line there that says that that's 21. Standard deviation is going to be 4, okay? So I'm going to do this. I'm going to say, if I would go 4 units and add 4 units to 21, this first number would be 25. If I would subtract 4 units, that number right here would be, 17, I think. I subtract 4. Okay, so these people in here, there would be 68% of all of my people that would be scoring between a 17 and a 25. Maybe this was an ACT score or something like that. So 68% of all people are going to score between a 17 and a 25 on the ACT, let's just say, okay? So find the range of values that represents the middle 68% of your distribution. Find the range of values. That range is going to be between 17 and 25, okay? That's my range of values, okay? Then it says what percent of the data will be greater than 29. Okay, so let's keep going. I'm going to add 4 again to each one of these numbers. Okay, so I added 4 here. I'm going to add 4 again. That's going to give me 29. And I'm going to subtract 4 here. That's going to give me 13. Okay, so I want to know what percent will be greater than 29 right here, from here and above. Okay, so if you kind of think about standard deviation, like the middle number being 0, this guy I've added 1 standard deviation. This one I've added 2 standard deviations. Okay. Here I've subtracted 1, and here I've subtracted 2, okay? Like basically, if my standard deviation was 4, I basically added the number 4 once to this number to get 25. I added 4 twice to this number to get 29, right? That's kind of another way to think about it. So they want to know what percentage is above 29. Well, 29 is at the positive 2, okay? So if I go to this curve, or you can use the one that's on that other sheet, the +2 would be at this spot right here, okay? And this, these numbers kind of tell me really nicely what those percentages are. If I'm looking at the +2, anything above that would be this guy here and this guy here, okay? which is 2.4%, and 0.1%, okay? So anything above here would be 2.4% and 0.1%, okay? If I put those two together, 2.4 and 0.1 is going to be 2.5%. So I can expect that about 2.5% of all of the people who take the ACT might score higher than a 29, okay? I know a lot of people that score higher than a 29 in an ACT. Those are the smartest, basically 2.5% of everybody taking it, okay? So that's kind of a way of thinking about how that works, okay? So what I'm going to have you do quick is look on this practice sheet. I'm going to go through a couple of more of these examples with you just to get an idea. 1, 2, and 3 are going to refer to this information up here. So 186.4 and a standard deviation of 48.9. It doesn't tell me what these numbers mean, but you know, I just go with it that way. So 186.4 is going to be my average, okay? And then I'm adding 48.9 each time. Okay, so I'm going to do 1, 2, 3 here, and 1, 2, 3 here. Okay, so this one I'm going to need a calculator because I have decimals. Okay, so 186.4, and I'm going to add 48.9. Okay, so this first number is going to be 235.3. Okay, if I add another 48.9, that's going to be 284.2. Okay, now I want to add one more set of 48.9, and I have 333.1. That's what he will look like. Okay, now I'm going to do the opposite direction. I'm going to start subtracting. So this one was like kind of like at 0. I was adding 1. I added it twice, and I added it a third time. Okay, here I'm subtracting it once, subtracting it twice, subtracting it a third time. Okay, so let's start back there and let's figure out what these numbers are. 186.4 minus 48.9. I'll try to go kind of fast. 137.5 minus another 48.9 is 88.6, and minus another 48.9 is 39.7. Okay, then it's going to ask us some questions. Okay, so I've got this drawn over here. It says what range of values represents the middle 99%, okay, or 99.7%. The middle 99.7% is within 3 standard deviations. So if I go out and I go down, that means everything between -3 and +3. Okay, so what numbers do those correspond to? The -3 number is 39.7. The +3 number is 333.1. So that's my data range. It says what range? 39.7 to 333.1. That's going to be my data set. Okay, what percent of data will be more than 235.3? 235.3 is this guy and beyond. Okay, and this guy is at the +1. Okay, so 235.3 is at the +1, which is this guy right here. Okay, so we have to figure out what percentage is above that from here on out. Okay, that's going to be 13.5% plus 2.4% plus 0.1%. Okay, so if I do that on my calculator, 13.5 plus 2.4 plus 0.1, okay, is going to be 16%. Okay, so 16% of my numbers are going to be there. And then it says, what range of values represents the upper 2.5% of the data? So this one's kind of a weird question. The upper 2.5%, okay, the upper 2.5% is going to be this 2.4 plus that 0.1. This is 2.5% right here, 2.5%. So where is that cutoff mark that represents the largest 2.5%? It would be this number right here, because anything larger than that is 2.5%. Okay, so that is going to be the +2 number, and my +2 number is 284.2. Okay, that's what he is. Okay, all right. So just answering some of those questions. That's how you go through those. All right. Let's see what the back side does. Yeah, let's do this one. Example 2, and then we'll quit. The heights of 1,800 adults are normally distributed with a mean of 70 and a standard deviation of 2. Okay, the whole 1,800 adults means nothing to me. That's just additional information. but they say a mean of 70, so that's my average. I'm going to put 70 in the middle, and then standard deviation of 2. Okay, so if I add 2, add 2, add 2, subtract 2, subtract 2, subtract 2. Let's get those numbers, okay? So the first one's going to be 72, 74, 76. This would be, what, 68, 66, and 64 with those numbers, okay? So we're adding 2 each time, we're subtracting 2 each time. I always like to put the 0 goes here, plus 1, plus 2, plus 3. I've added 2 once, I've added 2 twice, I've added 2 3 times. I've subtracted 2 once, I've subtracted 2 twice, I've subtracted 2 3 times, and I can kind of keep track of those, okay? About how many adults are between 66 and 74 inches tall, okay? So between 66 and 74, that's between -2 and +2 on my, like, number line here, okay? So using our empirical rule sheet, okay, between -2, which is down here, and +2, which is down here, okay, what percent is in between those two, okay? Well, I could add up each one of these 4 categories, right? But I know that if I'm going between -2 and +2, that would end up being 95%, okay? So 95% of all adults are going to be between 66 and 74 inches tall, according to the data that I have, okay? Part B, what is the probability that a random adult is more than 72 inches tall, okay? So now I'm saying from here and beyond, okay? So I want to know what percent is from here, 72 and beyond, okay? 72 is at the +1, okay? So on my unit circle, or on my empirical worksheet, I have the +1 is here, and what percentages would be from here and beyond? I think we've already maybe calculated this one. This would be the 13.5%, the 2.4%, and the 0.1%. I would add all 3 of those together, and if you remember that from before, that was, I think, like 16%. So it says, what's the probability? Probability a lot of times is represented as a percent, so that's what they're asking for, okay? So just kind of think of it, this bell curve, as like this area underneath of here is 34%. This area under here is also 34%. Okay, this area represents 13.5%. This area represents 2.4%, etc. You know, going all the way through. Okay, and then just if they're asking for greater than this point, it's just adding all of those up. That's bigger than that. Okay. So I hope this is all making sense. You know, I'm not able to get instant feedback from you, obviously, when we're on video like this, but hopefully that all made sense. We will finish this bottom part and do that in the next video.